Hi there, if you thought about cool and really nice science fair idea, here's one to build your own 8-bit computer on breadboards, and let me show you in a couple of minutes how this could be done. Why it's cool? First of all, it's a hands-on experience as any science project as it's meant to be, so you can build it and understand how computers work. Also, you can just add a personal twist to your computer. You just also can create some case for it, like colored case or something like that, so to express your personality. And also, it's going to be wow from your judges for sure, because it seems to be complex, but you can do it using this Breadboards kit. So let me show you what you can present, what can be the parts of this presentation on the science fair, and just give you a little overview of how you can actually build it, and how you can show the experiences. So there is example of real stand that really shined at one of the science fairs in the US. And so on the left side you see some pictures from the build process. Here you can see Apple One, the original Apple One that was built with this kit, and we see the year when it was introduced by Steve Wozniak and Steve Jobs, and you see the picture of them in front of this board PCB of the original Apple One. So yeah, you can have some part of that gonna explain what you're building and when it was created. The famous guys, it's always nice to show them and to add them to this stand. Then you can say about the components that you're gonna use, some integrated circuits, some capacitors, resistors, LEDs, and some wires, of course. And in this case, it's also batteries. But for sure, in real computer, you use pretty much power supply. Also, what is at the heart or the brain of the computer is a CPU, Central Processing Unit. And here's some analogy I can show, we are, as humans, we think with brain, and computer has a CPU that pretty much performs all the calculations. And also we have some display to show what's happening and to interact with us, and keyboard to let us input some information. So we have some output device, input device, and the brain do the work. Also, you can highlight binary code. So here's an example of how different English letters are encoded using binary code. And also there is the big table that is very famous and used everywhere. It's ASCII code table that also has not just letters, but also numbers and all the other symbols we can type pretty much. Experience, you can share your experience, and definitely, as any engineering project, it has some ups and downs, and one of them is you start smart, you don't understand what's happening at first. It's new things you need to learn and many things you need to understand, but then during the process you face some troubles you need to to debug and troubleshoot, but then at the end you're happy because you achieved that. You've built this computer and it's running. It's quite amazing. And yeah, so summary, it's fun. So you can also highlight something from your experience, what you liked most, or what was the hardest part, to understand maybe something or to wire something. Also, some historical part, it also highlights the evolution of Apple logos. So it gives your project this link to things that everybody know, and so it's really nice. So also there is an ASCII table showing all the symbols, how they're encoded in binary. So yeah, to summarize, so we have some build process on the left, some pictures where your kit is doing that. You have some historical, the insights here also, and also explanation how it works. And also every computer uses binary code, and so here you just can overview binary code. You can add arithmetics, you can explain the system of commands, so the CPU, for instance, what kind of commands does it have. You can highlight that, but in this case the ASCII was the most interesting part. Yeah, so this is the stand you can build, for instance, and also the process itself also includes having these modules where you insert the chips. So everything is pre-built and you just need to insert them, and they're like have all their inputs and outputs marked. So then you have the iPad or PC or Mac, some computer where you can follow step-by-step instructions. Also, you can check the original instruction just for inspiration, and you can bring it to the science fair. For the others, just to understand more the context of all this. Also, you would have keyboard. You need to bring your keyboard just to type something. But then, like, you have breadboards where you build step by step, insert modules, connect with wires, and then plug power supply and pretty much see the results. So this is the close-up, so in which you can see like the very simple but basic computing system, because here you can see CPU, address bus and data bus, showing here like that we have 8-bit CPU, because it's just 8 connection lines, and here we have 16 address bus lines, so we can address up to 64 kilobytes of memory. And we have memory module here that is quite clear here, so it's ROM, RAM, and we can show it also to the other kids at school that we have this connection between CPU and memory, which is crucial for every computing system. Here we have the generator clock, so that creates these ticks for CPU to work, and reset button, so that restarts the computer. And this LED here, it marks all the cycles of CPU, how it works, so we can see whenever it works, we see it like blinking. Here's the small display that just showing Mad with Love by SmartyKit, or here it's like the name of the kit in Anastasia. And so you can also explain like what is behind this technology, like pixels and stuff like that. Here's like overview, like also that you can connect keyboard, and also this is pretty much almost assembled one. And at the end you're happy, and yes, here we are, and your science project could shine, and you can really learn much more about computing, and also think about like maybe about your career, and to develop your knowledge in computer science and coding in hardware, and decide where you want to go next, and also get kudos from judges in your school, and become a local Steve Jobs or Steve Wozniak. And yeah, so whenever you're gonna think about the building new science fair projects, think about this 8-bit computer, and using this kit that doesn't require like a super skill set like soldering or whatever. So it's just you can sit it at home and assemble more like a Lego. Yeah, so yeah, have fun. Bye.